Myself Srinivasan, working as a faculty in the Department of Mechanical Engineering at Sri Shanmugha College of Engineering and Technology. The last couple of lectures we have been discussing about recurrent neural network. Today we are going to look at its implementation. So for that I am going to use synthetic data. So now we are going to look at this price of the stock, and these are the libraries to be imported in Python, and NumPy is for the numerical operation. So this is for the data manipulation, this is for the plotting, this is for the normalization, this is for the, since we use this in RNN, we use a stack of layers, and we use a sequential one, and in the simple I'm going to use a simple RNN with dense, and for the update bytes, and we are going to use the Adam optimizers. Okay, these are the libraries to be imported before we move on towards RNN. Since as I said, I'm going to use this synthetic data. Okay, synthetic data that will be produced by using random numbers. For the reproducibility, I'm going to use this command, and the np.random.seed42. The total number of time steps that we use 100. For the price, the initial price starts at 100, and it will be summed up by adding this the numbers that we get from the random. So finally, we should have the data frame, that x and y. And as I said, the initial one starts at 100. Okay, so this is a stock price varies as a function of 100 time steps. So whatever the value that we start, that is, for example, if we started at 100 and it has to be normalized. For the normalization, we are going to use this min max scalar. So what are the values that we get? It will be ranges from 0 to 1. Okay, so these are the values that we will get from here. So this is for the input sequence, this is for the output sequence. The total number of steps for the consideration is 10. Okay, so 10 previous times will be considered to predict. Okay, the next one is how we are going to implement here. Okay, the input sequence length is 10 steps here. For example, I can say 10, 20, 30, 40 and all, and suppose if I say for the simplicity, I will take 10. I will take very simple one, that is, in number of step is 3, and what about the predictor one is the next one. For example, 10, 20, 30 is my input. For example, 10 and 20 and 30 is my input. My output is going to be 40. So similarly, 20, 30, 40, the output is going to be 50. So this is a thing we can get from here. Okay, and for the hidden state, and whatever the value that we get from the input and whatever the previous layer time step that we get, all will be summed up and it will be activated there. For the case of here, this is for the input, this is for the previous weight, for this is a WH is the weight from the previous one, and this is here we use is a tan h activation function. So the value ranges from -1 to 1. Okay, so for the data, we are going to split up 80-20 as we do in normal most of the cases. Okay, so for the case of model, and we use this simple RNN and 50 neurons, and the activation function is tan h, return sequence is false, and input feature is input shape is number of steps, 1. Okay, see, for example, if I say 50 here, I use the 50 neurons in the hidden state will capture the pattern. Okay, and I use the tan h activation function over here, and it will capture all the data. That size is, suppose if it is 50, in the input size n step is 50 and 50 comma 1, that is the input shape. Okay, for the, I mean, if it is n step is 50. Okay, not 50 here now. Here we have used 10 only, so 10 comma 1. Okay, so similarly for the dates for the output layer, it is going to be for the predictions. So whatever that 50 hidden state 50 neurons will capture the pattern, and the final output is going to be 1. Okay, so this is what it means. So we compile this, and since we use the Adam optimizer and the learning rate is 0.01, and it is we are interested in mean square error. Okay, we have to reduce the difference between the actual one and predicted one. Okay, so when we go for 50 epochs and batch size is 8 and validation data states and all, and we are going to use this. We are going to train the model based on this, I can say. So once we get the CCAP, because initially we had 100 initial stock price is 100, and we accumulated based on the random number that we used, and we then again we are normalized for the when we normalize we got the values between 0 to 1. Again we have to convert back to the original one, and we have used this inverse transformations. So from this, when you do the epoch we got the losses very less and 0.0037, and if you look at this image and whatever we have got, whatever the actual value is very close to the predicted one. Okay, so what we have understood from this implementation is that, so here we are considering the previous input sequence to predict, and we are updating the weights using Adam optimizers. So that will help us to predict the sequential data or time series data. So this is what we learned in today's lectures. Thank you.